Okay, so I am going to recap on basic rounding, rounding to a whole number and to a given decimal place. We'll then look at rounding to what's called a given number of significant figures. I'll explain what I mean by significant figures and then how to apply this process. Okay, so rounding to the nearest whole number. We always, for any rounding, we're going to look one digit to the right. So you look at the first decimal place digit, so the first number after the decimal point. To the nearest 10, we look one place to the right, which is the units. The 100, we look at the tens digit, and the thousands rounding, we look at the hundreds digit. So the basic rules are for that digit that you're looking at, that's one place on, if it's a 0, 1, 2, 3 or 4, we round down. And if it's 5, 6, 7, 8 or 9, we round up. So we are going to illustrate these rules with some examples. Okay, so first of all, rounding to the nearest whole number. So we've got the examples of 3.659, 25.45, 409.999. So the nearest whole number means that we do not want this decimal point and we don't want any of the digits after that decimal point. We want to get rid of all of that. So in order to do that, all we're interested in looking at to decide in terms of our rounding is looking one place further than where we want to round. So we're rounding to the nearest whole number, so we're going to look one place past that, which is this first digit after the decimal point, and it's a 6. So our rule tells us a 6 means round up. Okay, remember 5, 6, 7, 8 or 9, round up. So that means that 3.659 will simply become 4. So notice no decimal point, no zeros after that, it's just 4. 25.45, the first value after the decimal point is a 4. Not interested in the 5, it's just this 4, this first digit. 0, 1, 2, 3, 4 means round down, so that's going to be rounding down to 25. It essentially means we leave that 5 as a 5. So the reason we say rounding down is because this number is actually greater than 25. It's 25.45. If you thought about it in terms of money, £25, 45, the amount of whole pounds it's nearest to is 25. So sometimes thinking of it in that sense can kind of help it to make sense for you. 409.999, so it's a 9 this first place. That means we're going to round up. However, rounding this 9 up means it becomes 10. So everything sort of moves one place along in terms of our number column. So 409 becomes 410. Okay, so rounding to the nearest 10, 100 and 1000. So we can't just drop digits off and not use them when it's rounding to tens, hundreds and thousands. We've got to replace our rounding values with zeros to hold everything at the correct place value. So 3121 to the nearest 10. So the tens column is this second column here. So we look at the units column, which is a 1, round down. So in other words, that 1 becomes a 0. It becomes 3120. To the nearest 100, it's 3,100, and the nearest 1,000, we look at the hundreds column, which is a 1, so again it's rounding down, and 3,000. So when it's the nearest 10, it ends in 1 0, nearest 100 ends in 2 zeros, nearest 1,000 ends in 3 zeros. So 7,489, so to the nearest 10, that unit's value is a 9, so that tells us we're going to round up to 7,490. To the nearest 100, again it's an 8 in the tens column, so we're going to round that up to 7,500. However, for the nearest 1,000, if we look along 1, so 7 is our thousands column, along 1 to the right is a 4, not interested in 8, 9, it's a 4, so it tells us that we round down, so it becomes 7,000. And then this last one, 16,554, very quickly, to the nearest 10, that's 16,550 because we're rounding down. Nearest 100, we are rounding up the way because it's a 5 in that tens column, so that other 5, the 5 in the hundreds column becomes a 6. Everything else is 0. And then the nearest thousand, so the 6 is our thousand, it's a 5 there, so it's going to round up. It's closer essentially to 17,000 than it is to 16,000, which again is this other way of thinking about it. So rounding to any number of decimal places essentially follows the same rules. So for instance, when rounding to one decimal place, we look one place onto the right at the second decimal figure to decide. So for this number 2.46, we look at the 6 to decide, to cut off basically after that one number after the decimal point. Two decimal places, we want two numbers after the decimal point, so we look at the third digit to decide. Three decimal places, we look at the fourth figure after the decimal point to decide if we're rounding up or down, and four decimal places, we look at the fifth decimal figure, or the fifth figure after the decimal point, and that helps us to decide whether we're rounding up or down. And we could keep going and going. The rule is the same: 0, 1, 2, 3, and 4, we round down. 5, 6, 7, 8, and 9, we round up. Okay, so here's an example here, a nice long decimal number, 4.2615937. Lots and lots of numbers after the decimal point here. So to round to one decimal place, all we have to do is we want to cut this number off after that first number after the decimal point. We're not going to replace it with zeros or anything like that. We don't need to. The zeros, when we replace whole numbers with zeros, it's to hold everything else in place. In this case, we cut it off because it makes no difference to the number. So we want to just have one number after the decimal point. So we look at the second number, it's a 6. So 5, 6, 7, 8, and 9 means round up. So that 2 becomes a 3 and everything else disappears. So it becomes 4.3. To two decimal places, we look 1, 2, we want those two numbers, and then we want everything else to disappear. It's a 1, so that's going to stay as a 6, 4.26. Three decimal places, we want to cut off after this 1. The next number after that's a 5, so we round up to 4.262. And four decimal places, so after the 5 we want to cut off, it's a 9, which means the 5 we're going to round up to a 6, so 4.2616. Okay, so all the rounding that we've looked at up to now has been our basic rounding to whole numbers, rounding to decimal places, but it's all basic. It's not actually National 5 level. Significant figures are a rounding where we're at National 5 level, and when you're asked to round at this stage, generally it's to a given number of what's called significant figures. So what we're going to do is look at understanding what significant figures are, and then how to round to those values. And it's because rounding to a certain number of significant figures isn't as straightforward as saying round to one decimal place or round to the nearest 10. Depending on the number that you're given, it could be either or something different. Okay, so what a significant number is in mathematics, a figure or digit is significant if it gives an idea of both quantity and accuracy. In other words, essentially what it means is zeros are not considered significant if they're only holding all the other numbers in place. Okay, zeros can be significant if they imply quantity or accuracy, and accuracy more or less, but if they're only there to hold numbers in place, then they are not significant. So let's look at some examples. It's actually clearer when you're rounding for the significant figures. So there's a few values there, and we're going to look at how many significant figures each of these values has. Now generally we start counting a number as significant from the first non-zero value in that number. Okay, so 506 has 3 digits. Okay, now it does have a 0 in there, but because the 0 is part of the overall number, in other words, it falls between two non-zero values, then it is also significant. It gives an idea of accuracy, that 0 in there. It's not just holding the other numbers in place. So that has 3 significant figures. 50.6 is the same. It also has 3 significant figures. So even though it's a decimal, the number starts at the 5 and ends at the 6, and after that there isn't anything else there. So it's 3 significant figures also. 0.506, however, this 0 here before the decimal point is just holding everything in place. That's how we tend to view that. So we don't start counting the digits as significant until we get to this first non-zero number, which is the 5. So again, this has got 3 significant figures. And again, if you look at this number here, 0.00506, so the first 3 digits are just holding everything else in place. So again, this has got 3 significant figures. So you can see that the 0 between the 2 non-zero numbers is always significant, but we don't count these ones beforehand. Okay, so when we're rounding to a given number of significant figures, the best way to go about that is to think about starting from the left-hand side of the number, that first non-zero number, and count along for however many significant figures you're asked for, and then round from there. So depending on the type of number that you have, if it's a whole number, you're going to have to round it and maybe replace one of the digits with a 0 that's a non-significant 0 to hold it in place in their correct place values. If it's a decimal, it means you can cut off after the amount of significant figures. But we'll look at these examples to see what it is exactly we do here. So this first one, 234, rounding to 2 significant figures. So starting at the 2, 1, 2, the 2 and the 3, we want a significant. After that, we don't want any non-zero values. So we need to round this essentially to the nearest 10. So the number after the third value here is a 4, so we don't want that. We're going to round down, and that becomes 230. We're essentially rounding it to the nearest 10, but we have to decide for ourselves what you're rounding it to, given the significant figures and given the number that it is. So here's another one. We want it to 3 significant figures, but it's 13,577. So the 1, the 3 and the 5, when we count along from the left-hand side, will be our significant figures. But that first 7, that 4th digit, we're going to round from there. Because it's a whole number, we've got to replace these 2 7s at the end with zeros. But we're also going to use that 7 to decide whether we're rounding up or down. It's a 7, so we're rounding up. So it becomes 13,600. Number 3, 0.256, when we're counting as significant, that 0 before the decimal point doesn't count. So the 2, the first digit after the decimal point, is the first significant figure. So we're going to, because it's a decimal, we're going to just cut it off after this, but we have to round. So the second number after the decimal point is a 5, so we're going to round up to 0.3. Number 4, 34,789. We want 2 significant figures here. So the 3 and the 4 we want to keep as a non-zero values, but after that everything else is going to be replaced as a whole number. So we've got 3 digits here that we're going to replace with zeros, but we also have to round. So it's a 7, so it tells us that the second significant figure, the 4, needs to go up to a 5, so it's going to become 35,000. 14.067, so the 1, the 4, the 0 and the 6, remember 0 between 2 non-zero numbers is significant, and then we're going to cut off. So the next value, the last value we've got there that we don't want is a 7, but it tells us we need to round that 6 up to a 7 to become 14.07. And the last value, you'll notice this is a number that's been written in scientific notation format. And we can apply rounding to scientific notation values as well. We apply it to the number. We don't need to worry about this value here, this times 10 to the power 6. That just stays as it is. It's this number here, the 5.4752. So we want 3 significant figures here. So exactly the same process. The 5, the 4 and the 7. We want those first 3 digits to be our non-zero significant figures, and then we can cut off, because it's a decimal, it's that numbers after the decimal point, we can cut off after that. But it's a 5, the first value that we're cutting off, so it tells us that 7 is going to be rounded to an 8. So our number is 5.48 times 10 to the power 6.